Hey, everybody. So this, I'm going to give a talk basically on code obfuscation. I'm Richard Wartell, Wartell. I work for Palo Alto Networks, doing reverse engineering. And this talk kind of stemmed from me writing CTF challenges and having some fun with it. This is kind of a tool demonstration talk where I'm going to talk about some code obfuscators that are out there and then one that I wrote. The code base is right here. It's called Redfishy Realness. Feel free to go and check it out. Also, my team is running a CTF that's starting in less than 24 hours. We're giving away like 16 grand and a bunch of other stuff. So feel free to check out labyrinth.com. That's going to be launching tomorrow. So let's talk about obfuscation. So the idea of obfuscation is you have something that you want to obscure. You have something that you don't want somebody to know what it is, or you at least want to make it hard for somebody to understand what it is. So for example, you have a dick butt, and you want to make it look like this. So, something like that. This is a general idea. Or like this guy. Make it look completely nondescript. So there's a lot of different obfuscators that are out there. Oh, by the way, I don't use bullets anymore. I just use horrible images, so enjoy that. This is basically going to be almost like that Salesforce talk that you saw earlier. So there's different kinds of obfuscators out there when you're talking about obfuscating a binary. You can talk about code obfuscators, like source code obfuscators, that are actually just obfuscating your source code. Or you can talk about obfuscation on the binary level, so things like packers and compressors. When you're talking about source code obfuscation, there's one of the first ones that comes up is different ways of obscuring your code. You know, when you're writing code, you'll put in things like very obvious function names so that you can reference things and understand them. Lots of source code obfuscators will go in and get rid of that and make them very generic, or make them even harder to read and harder to understand the references of, because they'll do things like adding, only using the letters I, L, and 1 for all variable names, so it's really hard to read. There's pros to this. For pros, it's really good at protecting like somebody looking at your source code. It's ugly to look at and it's a pain in the ass and people won't want to look at it. However, when you're talking about cons, which of these two is a convict? So when you're talking about cons, if you have a program that analyzes source code for you, it's not going to struggle with this at all. It's actually going to look at it and be like, well, there's still variable names. I know where they go. Cross-references will still make sense. It actually doesn't do much. Source code obfuscation usually doesn't do much in the way of protecting a compiled binary. So I added new images to this, and now I'm struggling. If you're talking, another one that you can talk about with source code obfuscation is adding complexity. So if you add complexity to the source code and you add things like function calls and random conditionals and different things, we sometimes refer to this as red herring code, code that makes you think that it's doing something when essentially in the end it's not really doing anything. It's really good at obfuscating it such that you don't know the end purpose because there's just so much crap in front of you that it's really hard to tell. So when we're talking about pros of this, it's great. Really hard to read, really difficult. Another benefit of source code obfuscation this way is if it's a compiled, if you're compiling that source code down to native afterwards, you're getting benefits of the obfuscation down in the native code as well, because you're adding a bunch of stuff which makes it hard to reverse when you're actually looking at the native binary as well. So you get benefits on both sides of that. In terms of cons, it adds a lot of code bloat. So if you have some mission critical code, like say I'm writing code for rockets or a satellite or something, every cycle probably counts and you really do not want to be adding a bunch of code bloat. So this is a kind of a bad approach when you have like mission critical code because you're going to add cycles, it's going to slow things down. Now, if we talk about code obfuscators that are only dealing with a compiled binary, you obviously talk about packing. So obfuscators that are, the delay there. Obfuscators, well, essentially packers that are just taking your code or your binary and they're encrypting or compressing the data inside of that binary. And then at runtime, they're pulling that data out and executing it. Obviously, there's some great pros of this. Makes it really hard to understand. If you look at the binary statically, you won't see very much. You're going to see a little bit of code and probably a bunch of encrypted data. Doesn't really do much in terms of reversing. However, however, in terms of cons, most of the time, at some point, this binary has to unpack its payload. It has to unpack what it's going to do and run that. So most reversers will just say, okay, well, I'll wait for it to unpack its stuff, and then I'll go to that point, and I'll just dump out memory, and I'll be able to get out what it's actually going to do. So it doesn't do much in terms of protecting long-term, because there's usually workarounds. There's also caveats to that, because there are some packers that I'll talk about, but usually that's the case for the majority of packers. There's also a couple of things in terms of obfuscation that just fall under like these unique territories. For example, like Obfuscator and Themida and VM Protect. VM Protect and Themida both work on single process virtualization. So they actually take your binary, or they have options to do so essentially, and they will take it and convert it to a different instruction architecture. So it actually uses different instructions in the binary and then translates them as the binary is executing. Really good because it's really hard to understand, makes it very difficult, and is pretty painful. We don't see a lot of this in the wild, surprisingly, because it's a huge pain in the ass for reversers, but we don't tend to see it very much. And then Obfuscator has to get a shout out because it's probably the coolest obfuscator I've ever heard of. I forget the author's name, but he essentially wrote an obfuscator based on the move instruction. So the move instruction is technically Turing complete, so you can use it instead of all other instructions. So he made an obfuscator that did that, so that when you open it in IDA and try to reverse it, you get this graph, which is 100,000 move instructions. It's really damn difficult to look at. And we actually have seen this in the wild, which is painful. But very, very cool stuff. Those kind of fall into more of the uniqueness route. So this is just a little bit of a background on all the different ways that you can go about obfuscating code. I was going about this as I wanted to write a code obfuscator to make CTF challenges. A while back, I started writing a CTF, and I needed something to make an ugly binary. I wanted one of my later challenges with a lot of crap in there. So this is when I came up with Red Fishy Realness. If you haven't seen Nick Cage Pokemon before, please go check it out. They're wonderful. So the idea behind this was I went through all of the ways of obfuscating code, and I decided that red herring code and adding a lot of just crap code to my binary was the approach that was the best for me. It gives you benefits in static code, in non-compiled code, so like an interpreted language, and it also can give you benefits in native code, so something that compiles. So it was really what worked best for me. So I went about this. I made a derpy little thing where I was just like, all right, how can I do this as simply as possible? So what I did was say that you have like this really stupid simple C program. And what this is it's just like a variable and like one actual code instruction and an import. Like that's all that's inside of here. And I even put really handy little comments so that I knew I could make the dumbest parser ever in order to read this in and then obfuscate it for me. So what I did is I take this and I convert it to this, which is just the imports, the global variables, and the code statements. This is just me generalizing what this looks like. So then I take the imports, and I just kind of crap fake imports all around it so that it's hard to look at. And then I take all the global variables and just go and vomit horrible global variables so you can't tell where anything is in this thing. And then with the code statements, I do the exact same thing, but it gets more interesting because with code statements, there's all kinds of things that you can add. You can add math, you can add functions that get called, you can add conditionals that actually aren't, that go a single way every time or are determined by some other variable that you control so that you know which way they're going to go. So I just spit a ton of code out into this thing, and it worked. The general response to the this was what I used for the 6th Flare-On challenge in 2014, and the internet basically said this. They did not appreciate. I saw a lot of GIFs of people that said, this was my day, and it was just a guy hitting the F8 button on a debugger over and over and over again. So it worked out pretty well for something that wasn't all that much effort. But I knew I could go deeper. I knew I could come up with something and actually make this viable and useful to somebody beyond my own horribleness. So what I did was I decided I need to figure out how to make this multi-language. I want to make something where I can actually parse a piece of code, and it doesn't matter what language it is. I can define, I want to make an engine that I can then add more languages to on the fly without actually having to spend a lot of time on. So that gets us into syntax. We have to talk about code syntax and how you can actually do something where you're abstracting away what it is to be the code. So let's look at Urban Dictionary, which is my favorite way to get information about the world. This is what Urban Dictionary said that the definition of syntax is. So it says the order in which words and phrases are placed on the computer. It's not exactly right. I like when they use it in a sentence better, because that one applies more. But essentially, syntax is a definition of the rules that control symbols in a language. So things like if and all of these keywords and these literals and stuff like that. So it defines how the compiler is going to understand that. The nice thing about syntax is it's very vague. There's a lot of ways to do this. This is one absolutely legitimate syntax. This is called brainfuck if you've never seen it. It's made of like 8, I think 6 or 8, I forget, different symbols, and that's it. Very, very simple language. If anybody's played Gorillas on QBasic, they've probably seen something like this before, which is totally a legitimate syntax. This is one of my favorites. This is another legitimate syntax for a programming language called Whitespace. And this is a demonstration of where the code actually is. But if you look at this in a text editor, it's just spaces and tabs, because it's all Whitespace characters, and they defined a language based on that. So, sorry? And new lines. And new lines, sorry. And probably both kinds of new lines. So the point is there's a lot of different ways to define syntax. However, those are explanations of ones that you don't see very often. I don't know many Whitespace or brainfuck authors. Like, they don't write it in that because that's not how people think. Most languages are made to be simple and understandable and easy to work with. So they all will have things like assignment. You have to be able to define variables, and you have to be able to assign things to them. They'll have math. You have to be able to do math. Everything tends to be based on math. They'll have conditionals. You have to have some way to define, if something happens, do X, otherwise do Y. You have to always have that kind of a functionality. And then finally, you have to have loops, because at some point you're going to need to loop or repeat something, and you don't want to write the same code over and over again. So this is vague ideas of what it is to define the majority of languages out there, like C and Java and stuff. I was looking at all of this and trying to figure out, okay, how can I dumb all of this down such that I can have one single engine? And so what I did is I looked at, this will be Python versus C. This is how Python does assignment. You just have variables, and then you have the value that you're assigning to them. In C, very similar, but you have to say what kind of variable it is. You have to define the type of the variable. And then they use semicolons. A little bit different, but pretty much similar. However, you can dumb it down to just this. So if I'm generating a bunch of random code, I can say, all right, well, I need a name and a value for Python. I need a type and a name and a value for C. Really easy to do. Same thing applies for conditionals. This is a conditional in Python. Just if X, do this code block, else do the other. This is what it looks like in C. Very simple, but we can dumb it down and say, all right, maybe I want one that always does the else statement. I will say, if a conditional that's always false, do a fake code block where I define a bunch more code inside of there. Otherwise, do a real code block. And we can dumb it down such that I just have strings that define, all right, well, this is what an if and else looks like, and now I just need to shove in the actual logic inside of there. So let's take a look at what you get from this. It looks really pretty when you disassemble it. So this is a binary in C. I'm pretty sure this is me summing two numbers. That's what the graph looks like. It's pretty ugly. So after putting all of these techniques together, you end up with something like this. It's pretty damn painful to look at. And works out pretty well if you want to obfuscate what you're doing. At some point in here, there's two variables getting added, and that's it. Like this, all of this is just avoiding that. I also wanted to make this very customizable. Obviously, sometimes I might not want to add 10,000 instructions for every add instruction. That probably isn't the best of ideas, but sometimes they do. So I have this all scalable, so the amount of recursion that I use will define exactly how much stupid amounts of code that I'm generating. So it works pretty well. So I did this, and I started writing it, and I'll demo exactly kind of how the engine works and what it looks like a little bit. I wrote the first one as kind of, I just abstracted everything away from my original C one and got that working. I have Python working. That was one of the first languages that I wanted to support, mainly because I find it funny that I'm writing Python to write Python for me. I also support Perl. If you don't know, this is a drag queen named Perl. I support C, because that was the first language and obviously what I used for that original challenge. And I support Golang now because I thought it'd be funny to support Go. And actually, the main reason I chose to go after Go was because they have just the derpiest mascot ever as the Go logo, which I just love. Also, Go is already painful to reverse, just like looking at Perl makes me want to throw up. So I thought, let's make both of those worse. So let's do a little bit of a demo time. Also, I love that if you Google Shrek images, you get random little kid drawings of E equals MC squared. So, oh, that's great. It's there, it's not there. All right, let's see. Can I do this? So, this is a giant JSON object that defines what it is to have a language for one of these obfuscators. This is my Python one, and all it's defining is different variables that I can have. So in Python, I've done a little bit more work and added more variable types. I support booleans and integers and characters and strings. I support lists of integers, lists of strings, dictionaries of strings to ints, dictionaries of strings to strings. I can support all of those in terms of the code that I generate. That doesn't mean that I can't support those types in the code that I'm obfuscating. This just means like I can use those types in the random crap that I'm generating. So I then have to define what it is to have a function. At some point, you're going to need to create a function and call it. I have to define that. This is conditionals. Like I'm only defining one type of conditional right now, but you can define more conditionals. This is different math operations. I have ways of handling addition, subtraction, adding Boolean stuff, adding bitwise stuff. These are memory operations, so just moving variables around, throwing things into lists. This is all of the code that it's just going to shove in there as code bloat when it generates this. This is string operations. And then finally, there's just some random features that I defined, like can this language support creating variables outside of functions, like global variables? There are languages that don't support that. I have a variable called must-use variables because when I started supporting Golang, it's actually a semi-intelligent compiler, and it'll be like, you're not using this variable, I won't compile. So I had to go and change everything I was doing and make sure that every time I make a variable, I actually use that variable in an assignment or in a math operation or something so that you can't have unused variables. So this is what it kind of looks like in terms of making a language, adding a language to the obfuscator. This is just a simple little Python script that I wrote. This is for getting, if you have a binary, getting the hash of it on disk, and then also getting the hash of it based on what the file says that it should be. It's a stupid little thing that I use in some of our reversing stuff, but it's got some lines of code. This is what the script generates. I can scroll for a while. It's pretty damn ugly. It spits out all of the stuff. If you wanted to be really ugly, since Python's interpreted, on top of this, you could then use a Python obfuscator that makes all the variables really stupidly named, even though they're already kind of ugly. So you could do all kinds of things with this if you wanted to make it even worse. So that gives you an idea of a little bit of what it does. If you do this for for native languages, I don't bring up IDA when I have an 800 by 600 resolution because your eyes will bleed. But essentially, sometimes you'll bring up IDA and it will say, I can't even open this in graph mode because you have like 30,000 nodes inside of this graph and I can't even display it because there's just too much crap inside of it. So fun stuff for making a reverser have a bad day. Oh, cool, and I'm back. So that's where I'm at with this. I've worked on it for a while, mainly for the CTF stuff that we've been doing. The next steps of this that I'd like to add, languages, obviously other languages and adding them to this. But thankfully, that's not the most difficult of things. Like, I'd like to add Java and C#, mainly because I want to write some CTF challenges in them. I'd like to add a couple other different languages. Right now, based on the way that this works, imperative programming languages are going to be the only ones that are really supportable. I don't think I could use my engine to do this with like a functional programming language, but I'm not 100% sure of that. So yeah, it works pretty dang well. And then in terms of other things, I'd like to do something with math. Essentially, one of the easiest ways to find leads when you're reversing something is to look for strings. It's just the truth that usually there will be strings somewhere that will give you some idea of what a binary is doing. So what I'd like to do is use, for every string that I find inside of a binary that I'm trying to obfuscate, actually creating a decoding function and then creating an encoded version of the string that at runtime it just calls the decode function. So looking at it won't tell you anything about it. It's kind of hard. I started already working on this, but it's a little bit difficult to do on the fly for different languages, but something that I'm working on. The other thing I'd like to do is just-in-time loading of libraries. So, one of the other ways that you infer some data about a binary or a script really early is looking at its imports, looking at what libraries it's going to use. So rather than doing that, I'd like to pull those libraries in at runtime because it'll give me the ability to hide that logic. And you can do that for compiled binaries and also for imperative binaries. Script languages. I love using this image because it's the best branding campaign I've ever seen, and that's a lot of sarcasm. I'd like to start doing something a little bit different with this, and that's trying to model the activities of benign code as like a mathematical model rather than what I'm doing right now. I'm defining what I think looks benign and would give a reverser a bad day. But if I could take a corpus of binaries that have benign activity in them and use those instead, I could then create a model and kind of try to shove that in instead. So I'd like to go down that road, but that's a little bit more for the research. So that's all I have. Like I said, the repo is up. It's called Red Fishy Realness. And yeah, I will take any questions. Yes. So the question is, can I actually make Perl worse? And the answer is yes. You can make Perl much worse. I actually I made a Perl challenge for this upcoming CTF, and then I had to, I used this to obfuscate it, And then I was told that I wasn't allowed to do that because the couple of people that tried to solve it, it hurt their brain too much and they did not enjoy it. Yeah.
Are there any interesting interactions between your generated code and compiler optimizers?
Currently, no, I'm not really doing anything with any compiler optimizations. You could totally throw that in as like your definition of the language. You could say these are the compiler optimizations, but I don't. No, so that won't happen really to my knowledge. I don't know, I mean, every compiler optimizer is going to be a little bit different, so I can't be like, no, it never happens. Obviously, it's possible. But the majority of the code that I'm generating is actually traversed. Like a good, I would say a good 50% of it probably is traversed. It's not like I'm just gonna spit a bunch of code and then at the end is like, oh, here's the original script. Like that would be pretty useless. So it does traverse that. So for example, when I'm creating a function call, that could be in a conditional that it does follow the one branch of that, and that's calling the function call, and then that's another function, and you can nest all of these things really easily. So all of the stuff that I try to make all of it used because dead code paths, like you're saying, are pretty useless. Any other questions? Sure. Oh, that didn't work. Sure. Cool. Well, thank you guys very much. Oh, sorry. I got one more back here. You can. You'll just have to pay me for it. I mean, this does happen. So, like I was saying, we've seen Obfuscator in the wild. The reason that I don't worry about talking about stuff like this and releasing it is, I mean, I release it because I'm writing it for CTF challenges. If I was out writing malware with this, that would be a dick move. But I would get caught, and then I wouldn't be able to live my lovely life in the United States. I'd, be down in Guantanamo. So it doesn't really happen that a lot of attackers will actually actively go out and use obfuscators like this. Like using Obfuscator is really damn ugly. Just out of the box, it's ugly, and then it's really easy to make it worse. So we've seen that in the wild, but we've seen it in the wild once, and it came out more than a year ago now. So I don't think it's something we really have to worry about. But yeah, sure, call me. I'll help. If you see this in the wild and you're like, oh, that Dick Wartell, then yeah, send me a message that starts with, hey, Dick, like, you got some work to do, because I think that's only fair. Anybody else? Cool, thanks a lot.